This is the 7th session in our Hot Topic webinar series. Borderless Learning provides these sessions so you can learn anywhere at any time. Borderless Learning is a company that offers training to help people achieve and maintain certifications that are necessary to win and perform work. This includes Cisco, ITIL, Microsoft, Mile2, PMP, and so many others. In addition to traditional one-week training classes, Borderless Learning offers training subscription programs for today's most important certifications. And these programs provide live virtual training as well as electronic courseware, giving you the best of all worlds for your training. The program also provides mentoring, so you can continue to get your questions answered throughout the one-year subscription term, and the ability to maintain current product knowledge with extended hands-on access to lab equipment. Contact us at sales@borderlesslearning.com. That's sales@borderless-learning.com to increase your value to your customers. So, with me today is your instructor, Jeff Hubbard. Jeff is a longtime instructor with us here at Borderless Learning, and as you can see, Jeff has a lot of experience with technology, having spent his entire professional career focused on communication technologies. Because Jeff believes in accomplishing the best results, he has invested a lot of his time and energy in becoming certified in the most current and relevant communication technologies. And Jeff also enjoys all things craft beer. Well, let's move forward and keep this webinar interactive. At Borderless Learning, we love questions, so please submit your questions in the questions section on your screen, and we'll keep them for Q&A portions of the webinar. Without further ado, I'm going to hand it over to Jeff.
Well, thanks, Hillary. Actually, some of the things that we're going to be going into today is kind of a high-level, very cursory overview on networks and computer networks and the different types of networks that you may come across in the IT industry. And to break this down, essentially, whenever we buy a brand new computer, a smartphone, a tablet, whatever it is that we have, one of the first things we have to do is we have to connect it to the internet. So that we can download applications, send emails, stream TV episodes, whatever it is that we want to do. In that process, we are actually joining a network. We don't just immediately hop out to the internet. There are several iterations and several phases that we go through in order to join the network. So, and there are different types of networks that we would join. So, amongst the types of networks that we would have are, we could have a very small network, let's say in our home, where you would have your local access point, your local router that you would join, and then that would further relay your communications out to your internet service provider, which would further relay your communication out to maybe a server at Google, something like that. All of that relies on a common set of rules that all of these devices subscribe to in order to, so that they can all communicate together. And these rules are broken down. They're otherwise known as protocols. And there are dozens and dozens, if not hundreds, of protocols that are in play in the networking industry. So all of these protocols working together is what makes communication possible between the devices. It allows us as the users to communicate efficiently using a wide variety of options. And it also allows not only to gain information or to access information, it also allows us to share maybe files. We can download files. Some of you may have you hear it called in a workplace a shared drive that you would access, and you keep common documents all on the shared drive so that people can get to that. Well, you have to get to that over a network, and we're going to talk about the various kinds of networks that we would use to get that. So all of the networks, however, have to operate on there's a common framework of rules called the Open Systems Interconnection Model that applies to all the networks out there. There's a variation of the OSI model. It's called the TCP model. It's broken down a little bit differently. But for purposes of illustration, we're going to go into the OSI model. And the OSI model is actually broken down into about 7 layers. And people that are going into networking, they kind of get tied up here in the OSI model because it's not the most intuitive thing to begin to understand. Here's how I kind of summarize the OSI model. It's a bunch of rules. That's what it is. It is a bunch of rules based upon for manufacturers of applications or of devices that apply to how your device or how your application communicates with others. If we can have a common framework of rules that allow for all of these devices to communicate, then it doesn't matter who manufactures it. Everybody can communicate in somewhat of an efficient fashion. And we break this down based upon the function of the device or based upon the function of the application. There are different protocols. Remember, I talked about protocols earlier. There are different protocols contained within each layer. So we have in layer 1, we begin with the physical layer. And the physical layer is essentially the set of rules that governs all of the physical connections of your device. If you physically connect a cable from your computer to your router, all of the specifications of that cable are all governed here in the layer 1 area. This is Ethernet is a layer 1 protocol. USB is a layer 1 protocol. Wi-Fi is a layer 1 protocol. They're all protocols. They do not care about how an application operates. They only care about how ones and zeros cross the network. Well, once I can get those ones and zeros off of my computer across that wire, I end up usually going to a switch, and that switch deals in the layer 2 area. Here, let's go ahead and I'll just do it from my end, Anthony. Don't worry about it. At the end of the presentation, I'll unmute everybody's mic in case everybody has any questions. It's actually going to be easier for people to ask questions through the chat function, however. So in the layer 2 area, this is what we call the data link area. Ethernet also operates here in the layer 2 area. But now we can have switches communicating with each other here in layer 2. And then further, after we leave layer 2, we go into layer 3. And layer 3 is our network layer. The network layer is where routers operate. There's a difference between routers and switches. And layer 3 is where routers operate. This is where most of you know about something called an IP address. The IP address is a layer 3 protocol, internet protocol. The IP address of your computer is 192.168.1.5. That IP address and how we would be able to find your computer using that IP address, that is governed in layer 3. And then these layers are actually also known as the media layers. This is where all of the information that is important to your computer is contained. Now, once we get out of that media layer, I've got to get this information really kind of out of my house. I have to get it out to the internet. And there is a whole series of layers that are responsible for how that operates. If I go over here into layer 4, into layer 4, that's called the transport layer. I'm not going to spend a lot of time on the transport layer, but this is these are the layers that govern, let's see, the quality of service of your of the packets, things like flow control and things like that. Firewalls tend to operate in the layer 4 area. And then later on, we can go into the session layer. Typically, the session layer is where the some of your encryption happens here in the session layer. So once you get this, the packets kind of out of the house and the, as it were, the protocols governing encryption and things like that happen in layer 5, and then that moves on also into layer 6. Layer 6 is where a lot of the encryption happens as well. And then moving on to the application layer, and this is actually the layer that sits on the HTTP, HTTPS, file transfer protocol, domain name service, things like this operate way up here in the application layer. So if you kind of run through this process here, you can see that when you would have, for example, you would have, let's say, a Google application on your computer, and on the Google application, you want to go to Google and you want to say, hey, what are the show times at the theater tonight? So that application, your Google, your browser, is actually going to encapsulate that request, and that happens right there in that application layer. And then from that application layer, it then hands it off to the presentation layer that begins to set up a lot of the encryption protocols. It then hands it off to the session layer where it does its thing. It actually handles net BIOS layers and things like that. And then it kicks it off to the transport layer where it's going to begin saying, how are we going to package this information in order to send it out off of the computer to the internet. And once it begins doing that, it then gives all of those individual packets, because all of that information has to be broken down into individual packets. It takes all of those individual packets and it says, hey, here's how I'm going to break these things down into packets. Here's the IP address that I'm coming from. Here's the IP address that I'm going to. And there might be some other instructions as well sitting in that information. And then on top of that, we have our frames and the routing information just to get, before I can get out to the internet, I got to get to my switch. So I have that information, and then the NIC card, the network interface card on my computer has information on there that says, all right, here's the ones and zeros that I'm actually going to send off. And everything is packaged up in this very logical sense, and it actually goes out to your switch where then it's handed off to the routers and goes out across your internet service provider, goes out to Google, and at some point there is a computer at that other end that then says, oh, I'm getting all of these ones and zeros in, and it sees the physical layer and it breaks off the physical layer or in this case the network layer, and it begins to break things off layer by layer until it can get down to the actual information that you sent, that you actually requested. And that's the general process, how data will move from one computer to another, whether it's inside your building or all the way across the globe on some sort of a network search. Layers 4 through 7 are typically called the host layer. These are and as I just described, these are the things that are actually happening right on your computer. So we can talk about different types of networks that we can have here. And one of the basic things we want to talk about is what sort of networks, what components are involved in a network. Well, we can have, it all starts at the network interface card on your computer, but it has to plug into something, right? And then you have other devices like switches. It typically will plug into a switch, which then plugs into a router. And then that might plug into a modem of some sort, maybe a cable modem. And, you also have firewalls and things like that. These are all elements that we have in these networks. But the way that all of these devices are interconnected with each other is really what defines the type of network that we're going to have. There's actually some obscure forms of networks, or you don't see them much. Things like personal area network, I don't really see a lot of that. Or you do see a lot of storage area networks and campus area and metropolitan networks. These are not things that you see referred to a great deal. But the things that we're really going to be focusing on here are local area networks, wireless local area networks, wide area networks, and virtual private networks. And I'm just going to give you some a pretty high-level rundown on how all of these networks work. So a local area network, this is something that you have in your house. You have, let's say you have your wireless modem in your house. What is inside that wireless modem that you have that connects to, Cox Cable or Comcast or Charter or whoever, that wireless modem has within it a switch, it has a router, and it has usually a modem, all built into the same little box. And a local area network is typically in a single building. You would have a single local area network, and if you go to work and you have a whole bunch of computers in the same office area, this is what we would call a local area network. Now, you could have a whole bunch of local area network computers that were all communicating with each other just fine. Maybe you have a file server that you're keeping a bunch of community files on. Maybe you have a print server that so everybody shares a printer. All of these computers can actually communicate quite well with each other on the local area network, and you don't really have to have any access to the internet for all of that to happen. All of these computers are communicating amongst themselves using all of those network protocols that we previously discussed, all on this local area network. So the high-level definition of a local area network is it is a network of computers or a network of devices. It can be computers, it can be servers, it can be printers, or any number of network-capable devices, and they are all on in your local area, typically under one roof. You would have a single, well, most likely a single router that they would all point back to. So these are all different devices that are all on a local area network. But what happens if we have multiple branch offices? And we have a file server maybe in the New York office that the Los Angeles people need to get to, or maybe I want to print something to my colleague's office from the New York office, and I want to say, hey, I'm gonna run this to the printer, but I'm going to print it over in your office so you can take this document and do whatever you need to do with it. Or any number of, maybe I have an email server, and that email server is kept in the New York office, but the folks in Los Angeles, the folks in San Francisco, they all need to access that server. Well, I can't just run a cable from New York to Los Angeles or from New York to San Francisco. I can't just I open up an office on Elm Street in Los Angeles, and I want to go to Fifth Avenue in New York. I can't just run a cable over there. So I'm going to use some pre-built infrastructure. I'm going to use internet service providers or any number of resellers that will sell essentially connectivity between offices. And there's several different ways to do this. MPLS happens to be the most common at this stage. Back in the day, it was something called frame relay. But these were all different protocols that we use to connect multiple offices or multiple locations. But we connect them in such a way that it's the same as if they were all in our same office. We are all on one secure connection between offices. So it still acts like a local area network. It's just that the computers, the hosts, happen to be in different locations. So we can take that local area network philosophy and spread it across the country or across the globe and use service providers to provide that connectivity between us. But in terms of the end user behavior, It's exactly like if they were in the same office with us. So that's a wide area network. Now, there's another way that we can do this. We can also have a network where we see this in our homes. I'm quite sure we have this in our home. And this is a wireless local area network. Now, the wireless local area network works just like a wired local area network, except guess what? It's wireless. And the way that this usually works is you'll have an access point, usually your wireless modem in your home. But let's say I have a large office. I can have several wireless access points. They're called WAPs, WAPs, wireless access points, distributed around my office. And all of my computers, or many of my devices, can all be operating on Wi-Fi. We're all familiar with our Wi-Fi hotspots and accessing our Wi-Fi. So this is the easiest way to describe this is it happens exactly the way that a local area network does, only using wireless connections instead of wired connections. But a lot of people forget about this as an alternate type of network. And when you're going into network engineering and things like that, you need to understand that there's a whole extra area of infrastructure that is required for these, depending upon the complexity of your environment. So that's wireless networks, wireless or WLANs, wireless LANs, wireless local area networks. And then lastly, in terms of our inside network, remember, everything that we've been talking about now is just how computers in our environment communicate with other computers or devices or servers or printers or file sharers or whatever, communicate with all of these other nodes inside our environment. We have not yet gone out to, quote unquote, the internet yet. We haven't gone out to the world yet. These are all just ways that all of our devices can communicate with each other in our environment. Well, we've talked about how we can do that in an office. We've talked about how we can do it wirelessly, and we've talked about how we can do it across several offices. What happens when somebody sits at home and they want to work from home? There's a lot of telecommunicating going on these days. So if somebody wants to do this from home and sit in and connect to a network just from home, maybe I want to connect to my company's network from like right now. I'm actually in Boulder, Colorado, and I can connect to Borderless Learning's network using something called the virtual private network. Well, let's look at what is involved here in order to do this. In order for me to connect to my virtual private network, I'm going to have to establish a very secure connection so that I can connect to Borderless Learning without violating any level of security with my mute that one. I can connect to Borderless Learning's Borderless Learning's network without, violating any security protocols or putting my information out there. And in order to do that, I basically establish a virtual tunnel between me and Borderless Learning, and I use a special router to do that. We can't go very deep into virtual private networks and how they work, but that's what it is. It allows me to have a private network from a public location. I can either use an application on my computer to do that, or like a soft client on my computer, like Cisco's AnyConnect is a popular VPN application. I can use something like that and set it up with my network, or I can use an actual router, a special VPN router. But it establishes a secure connection between me and my host environment, and allows me to do it in a public location. So now, after we've gone through all of the types of network, up till now we've been talking about doing all of this internally, just within our offices or within our variety of offices or from a remote connection using the VPN. But now how do we get out to the internet? Well, the internet itself is just a connection of a lot of different networks. That's all it is. I just saw somebody had a thing posted at one point that said, they said, there's no such thing as the cloud, it's just somebody else's computer. And that's really what it is. The internet is full of thousands and thousands and thousands of servers out there with all of the information that we need, and they're all connected in the same way that the local area network and the wide area network and the VPN, all of these are connected in roughly the same way that allows the interconnection of all of these devices. And it's all done through IP addresses and now IPv6 addresses, and giving us the access to all of the resources that we may need out in the future. And now about 78% of IT delivery by the year 2020 is all going to be out on the internet. People are saying, why should I have all of this information internal in my company when another company down the street has the same information internally in their company? Why can't we just all go out to the cloud, hold applications, hold devices, hold resources out in the cloud, storage out in the cloud instead of inside my walls? It's far more cost effective. And this is where we can bring things kind of full circle and raise the level of connectivity. And also raise the level of simplicity for all of our devices. So that's kind of the 20-minute high-level overview of how computers connect to each other. Clearly, we've only begun to scratch the surface on this. These are we can go far deeper into any of these areas, and Borderless Learning has a whole host of classes depending upon what your needs are in terms of going farther into to dive down into whatever it is that we can help you learn.